Hello students, today we are going to see classification of the elementary particles. Before coming to the nuclear and particle physics, we are known of very few particles like protons, neutrons, electrons and sometimes positron. But there are a large number of particles are present in the universe and we need to classify them. There are different methods to classify the particles. Sometimes these particles are classified on the basis of their masses, sometimes they are classified on the basis of their charges. But here the most famous and well-known method is a classification based on the reaction in which they take part. Okay, so basically the particles can be classified into two types. The one which take part in a weak interaction and one which take part in a strong interaction. So the particles which take part in a weak interaction are called as electrons, whereas the particles which take part in a strong interaction, they are called as hadrons. Okay, so we know that in a universe, four types of forces are present. Starting from the weakest force, the gravitational force, then electromagnetic force, weak nuclear force and a strong nuclear force, out of which the electromagnetic force and the weak nuclear force, the particles which take part in these two reactions, they are called as the leptons. Okay, and the leptons are of many types, like the electrons, which is a well-known example of a lepton which we regularly have heard of. Okay, then neon, then tau and photons. These are called as a leptons. These are called leptons because they take part in a weak interaction. I'll write it here somewhere. So they take part in a weak interactions. Or the muon and a tau are nothing but the heavier versions of the electron. Like the muon and tau also has the charge of -1. Okay, but this muon is heavier than electron and this tau is more heavier than this muon. According to the law of the parity in the universe, whenever there is a particle, antiparticle exists. Okay, so we know that the antiparticle is a particle which is having the exactly opposite charge but the same mass. All the properties are same but the charge is different. So that particle is called as an antiparticle of that particle. For example, electron with the same mass but the opposite charge, that is called as a positron. So I'll write it here. So this is a positron. Now this is an electron, this is a muon and this is tau. So this is called as a positron. This is a anti-muon and anti-tau. Okay. So whenever there is a particle, antiparticle exists. So the antiparticle of the electron is called as a positron, then muon, anti-muon, tau and anti-tau. Okay, you understand the relation between this. These are the particles and these are the antiparticle. Antiparticle is the one which is having all the properties are same, like mass and then spin, everything is same, only the difference is charge is opposite. So that particle is called as an antiparticle. Okay, and yes, there are few reactions, like in my previous videos we have seen that the negative beta decay process or the positive beta decay process. So in these reactions we have seen that whenever some particle like electron is emitted in any reaction, along with that reaction some neutrino is evolved. So when electron is emitted, so it is always emitted with the electron neutrino. Okay, so we will speak about this neutrino in details in some another lecture. Okay, so whenever muon is emitted in any nuclear reaction, any weak nuclear reaction, then muon neutrino is also evolved along with this muon. Okay, same with the tau. Okay, so this tau neutrino is emitted along with the tau. So antiparticles also have their neutrinos. So when positron is emitted, positron neutrino. So whenever in any nuclear reaction, you just keep these things in the mind, because this neutrino has never come into the picture. But if you are taking any nuclear reaction, weak nuclear interaction or the weak nuclear reaction, so whenever this electron is evolving, it is always evolving along with the electron neutrino. Okay, so all these particles are called as a lepton. Yes, one more well-known lepton is a photon. So we can see here this electron, muon and tau has a spin half, whereas this photon has a spin 1. Okay, so all these particles, these take part in a weak interaction. So all these particles take part in a weak interaction and therefore they are called as a leptons. Yeah, before coming to the nuclear and particle physics, we were well known only with the electron, positron and photon. But here we can see that lot of elementary particles are present in the universe and we need to classify them. Okay, this is why we are studying this classification of the elementary particles. Okay, so the hardons are the particles which take part in strong interaction. I will write it here. So I can write electromagnetic force, gravitational force, weak nuclear force and strong nuclear force. Okay, I'll write it here only. So the hardons are the particles which take part in a strong interactions, and the hardons can be again classified as a mesons and a baryons based on their spins, where the mesons have the 0 spin and the baryons can have the spin like 1/2, 2/3 and etc. Okay. So the mesons can take part in a strong interactions, like in my previous videos we have seen the interaction at the high energies, whenever there is interaction between the proton and a neutron at a very high energy. For example, the scattering experiments we have dealt with. So if you have taken a proton and a neutron is coming with a very high kinetic energy, like the kinetic energy of the 1 giga electron volt or more than 300 mega electron volt. So at that time, whenever there is an interaction between this proton and the neutron, so these particles are involved in those reactions. Okay, so these interactions are the very strong interactions. Those come under the strong interactions. We call them as strong nuclear force. Okay, so the pions, so the mesons can be again classified as pions, kaons, eta, F, D, B. Many pions are there, many mesons are there. So the pions are again of 3 types: pi plus, pi minus and pi 0. Kaons are of 2 types: k plus, k minus, and eta is only a singlet, eta 0. If any particle is present in 3 different forms, it is called as a triplet. If it is present in 2 different forms, it is called as a doublet. And if it is present in a only single form, then it is called as a singlet. Okay, so what are these triplet, doublet and singlet, and what is their structure, that we are going to study according to the standard model. Okay, in this mesons, these pions are called as a strangeless mesons. I'll write it here. These are also called as a strangeless mesons, whereas these are called as a strange mesons. Okay, why these are called as a strangeless and why these are called as a strange, that also we will see. But initially you should know that these pions are lighter versions, like they are having the weights of the nearly 130 or 134 MeV, whereas these strange mesons or these are having the range of nearly 500 MeV and above, nearly up to 5000 MeV also. Okay, now baryons are again classified into 2 types as a nucleons and the hyperons. Nucleons are very well known. The protons and neutrons are collectively called as a nucleons. Proton has a positive charge, whereas a neutron is a neutral. Okay, so these hyperons can be again classified. There are n number of hyperons are there. Okay, like few examples I have taken, like omega, lambda, sigma and cascade. And as I had told previously, If the particle is present only in one form, it is called as a singlet. If it is present in three different forms as sigma plus, sigma minus and sigma 0, it is called as a triplet. Okay, so this is how we classify the elementary particles in the particles which take part in weak interaction and the particles which take part in a strong interaction. So here I have written one more table which says it is a standard quark model. Okay, now what are these quark? And this chart completely explains about the four types of the basic forces which are present in the universe. Okay, so four basic forces are the electromagnetic force, gravitational force, weak nuclear force and a strong nuclear force. Okay, so the particles which take part in a strong nuclear interactions are these. So these particles take part in a strong nuclear interaction. So all these particles. This standard quark model is according to the quantum electrodynamic theory, which says that whenever there is an interaction between any two particles, that happens due to the exchange of some particle. So suppose if there are two particles and if they are attracting or repelling each other, there must be interaction between these two particles. This is what this quantum electrodynamic theory says. Okay, so the strong nuclear interactions are mediated by, so this up quark, down quark, charm quark, strange quark or top quark and the bottom quark. These exchange particles are called as a gauge bosons. Let me write that word here. So the exchange particles are called as a gauge bosons. So the gauge bosons which are involved for the weak nuclear interaction are these electrons, muon, tau, these neutrino and their antineutrinos, these particles and their antiparticles. Okay, this is Z boson and W plus and minus bosons. So these are the all particles which take part in a weak nuclear interaction. Now, according to the quantum electrodynamic theory, whenever there is an interaction between any two bodies, there must be some exchange particle. According to the quantum electrodynamic theory, so the gravitational force field, that must be also due to the presence of some exchange particle, but we haven't found any exchange particle for this gravitation. So we have assumed that particle as a graviton. So the graviton is a gauge boson for the gravitational force field. I'll write it here. So graviton is a exchange particle or the gauge boson for the gravitational force, which we have just assumed it. We haven't found it yet. So these photons are responsible for the electromagnetic force, which we already know. Okay, so the standard quark model explains everything about the four different types of the forces. And these particles, the quark model explains, or these quarks are the basic building blocks for all these elementary particles. Now how these quarks make these different elementary particles, that we will see in my next video. Thank you for watching.